Hi everyone, thanks for joining us tonight. My name is Riley Logan, and I'm currently serving as the president of the student chapter of SPIE at Montana State University. And you're probably wondering what SPIE stands for, and though it sounds like it's a club dedicated to undercover agents, it's actually something that I think is much more fascinating. SPIE stands for the Society of Photoelectric and Instrumentation Engineers. So in other words, it's an international society for people who think that optics and photonics is a really neat field to study. And we're in a great place to be studying optics and photonics. Bozeman is absolutely exploding with different photonics companies. And these companies develop products ranging from laser systems to help navigate self-driving cars, all the way to developing imagers that can see hundreds of different colors. And so obviously it's a great time to be studying optics and photonics, and Bozeman is a great place to be. So we want to show you some of the cool properties of light and some of the things that we do on a day-to-day basis. So we want to take you through a demo that hopefully you can follow along with at home, or you can review this video later and do it on your own time. Now to do that, I'm going to introduce you to our Vice President, Erica, and she'll take you through a really cool demo. Thanks.
Hi, I'm Erica. I'm the Vice President of SPIE, and today I'm going to walk you through a demo you can do with pretty simple things you should have at home. We're going to use some milk, a clear cup that will fill with water, some polarized sunglasses, and a flashlight. Okay, so the first thing we're going to do is look at what happens when we add milk to water and shine light through it. So first, using a flashlight, I'm just going to shine through the water, and we can see that the color doesn't really change of the light when it goes through the air next to the cup or when it goes through the water in the cup. Now, we add just a splash of milk, just really only a tiny bit. And then mix it up. So we're making a solution now, but it's not a homogeneous solution, which means that it's not really fully mixing together. Instead, there's still little droplets of milk floating around in the water. So now that we have the milk particles in the water, we can compare what happens to the light as it passes through the water mixture in the cup versus through the air. So when it's going through the air, the light still looks pretty white. But when it goes through the cup, we can start to see it's turning orange on the paper and turning blue in the cup. So what's happening is the milk particles in the water are scattering the blue light. And that's why they're now going into the cup, and instead of going straight through, they're bouncing towards the camera, making it look blue. Whereas the light that's orange goes all the way through the cup, doesn't scatter very much, and reaches the paper, which then, when it bounces off the paper and goes to the camera, still looks orange. The next thing we're going to do is look at the polarization of scattered light. So to do this, the first thing I did was pour out half of the mixture from before and then just add water to the mixture remaining. And this reduces the amount of milk that's in the mixture. And now you can do this using just an ordinary pair of polarized sunglasses, but I'm going to use this circular sheet polarizer just because it demonstrates the effect a little bit better. And you can see now the light that's scattering towards us is polarized, which is why, as I rotate this, the brightness of the light is changing, because the polarizer blocks light of different polarization states. So that's the end of our demo. I hope you enjoyed it. Thanks for joining us. I hope you didn't spill too much milk on your counter, and enjoy the rest of the evening in science.